question 1, it says A and B are points on a straight line as shown on the graph below. So we have A and B, and we have the first question: write down the y-intercept of the line AB. Now the y-intercept is obviously where it's crossing the y-axis. So this is the point over here. It's going to be 6. And then when writing down what that is, the y-intercept, we would usually write it like this: 0 and 6, where the 0 is for your x and your 6 is for your y. You could also write y is equal to 6. That would be okay. Then it says calculate the gradient of the line AB. So your gradient is the same as the slope. Now here we have our formula. Let me just bring them up here. We have the gradient, or the slope formula, is given by this formula over here. Now you've got here a y2, y1, x2, x1. So you need to label one of these points 1 and the other one 2. So let's say I do that. Therefore this would be x1 and y1, and this would be x2 and y2. So when putting into my formula here, my slope is m is equal to y2. y2 is going to be 2. So it's going to be 2 minus my y1, which is 5, divided by my x2 is 8, minus my x1, which is 2. So we're going to get 2 minus 5, which is minus 3, and we're going to get 8 minus 2, which is equal to 6, which is equal to negative 1/2. Then it says the acute angle between the line AB and the x-axis is 0. Show theta on the diagram. Sorry, not 0, it's theta. Show theta on the diagram. So let me just clear this. So we're going to have theta is going to be this angle here, that angle there. Could put it there, or probably the best place to put it would be over there, because there it's showing between your line and the x-axis there. And then calculate the size of theta. So in doing this, we could do it a number of different ways. We could use our small triangle, we could use our big triangle. I'm going to do it this way over here. We are going to have this triangle, make it this big triangle over here, and we've got our theta there, and this is 6 and this is 12. Now because it's a right angle triangle, I have my SOHCAHTOA, so I have sine of theta is equal to opposite over hypotenuse, cos of theta is equal to adjacent over hypotenuse, and the tan of theta is equal to opposite over adjacent. Now remember, we need to label that. This, according to my theta is my opposite, and my 12 is my adjacent. So I can use the tan of theta. That would probably be the easiest one to use. So I'll go tan of theta is equal to opposite, which is 6 over 12, like that, which is equal to a half tan of theta. And then I'm going to do the inverse tan of 6 over 12. Now remember to make sure that your calculator is in degrees. So you push your section, the second function, tan, and then you're going to do 6 divided by 12, close bracket, enter, and you get 26.56. Now I'm going to write that my theta is equal to 25.6 degrees, like that.